and it's 30 minutes now, and let's have a look at the temperature of the gauge. Now it's indicating what, 23.7 degrees. So we'll record that down in our table. Alright, now we'll have a look at the suction line pressure before we adjust anything. As you can see from the left knob, the pressure is 175 psi. Now that's way too much, and we'll have to purge the system and reduce the pressure accordingly. And now we'll take a look at the ammeter before we do any adjustment. As you can see, the amp is indicating the consumption of 2.2 to 2.1, and let's call it 2.15 as the figure. Okay, now Nur Hayati is going to purge the excess gas from 170 psi down to 150 psi from the suction line, and it's going to be done in 5 seconds interval, and after that we'll close back the valve and wait for the system to stabilize for another 15 minutes before we get the reading from the suction line pressure again. And she's gonna go ahead and do it. Banyak sekali, buka banyak. Kepak. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, after half an hour, you can see that the whole system is now stabilized, and let's have a look at the ammeter reading. It's indicating 2.1 and 2.2, 2.1, yeah, 2.1, and let's look at the pressure again. Now it's indicating 150 psi. Yep, 150 psi. So this is the condition of the system after half an hour of operation. And let's take a look at the coil temperature. Okay, it's been more than 30 minutes now, and let's have a look at the coil temperature. And as you can see, it's doing 22.4, and it will continue 22.4, and it will be modulating from 22.4 to 23 as per the thermostat that's automatically, and now it's 22.2. Then because of the automatic system, it will modulate between this lowest figure and way up to 23, I think, if we wait long enough, and then it will come back to 22.2. This is how the system works. So we'll record this figure down. Oh, now it's even lower, but in any case we'll use a ballpark figure of 22. Okay, 22 degrees. Okay, now she's going to show you how to remove the suction pressure line and from the manifold gauge, and she's going to go ahead and do it. And she's going to go ahead. There you go. And she's going to tighten the knob and remove the ammeter. There it is. There it is. Okay, so let's crunch some numbers. As you can see, the ambient temperature was 30.4 and stayed at 30.4. Now the static pressure is 250 psi. You'll be able to see this number as soon as you switch off the air conditioning unit for about 5 or 10 minutes. And you will see this on the manifold pressure gauge if it is still attached to the unit, which is not shown on the demo. The suction pressure is 170. Remember, it was a bit over pressure, and after purging it became 150 psi. The amp, we started off from 2.15 amps, and it became, after purging, it became 2.05, giving me a difference of 0.1 amp. And the coil temperature was 23.7 and it became 22.3, giving me a difference of 1.4 degrees Celsius. And here are some notes for the R410A only. The heat pump or the compressor, 1 horsepower, can give you an average of 8 to 12 degrees temperature drop. But realistically, from what I see, you can get only about 8 to 10 degrees. If you can get 10 degrees, you are very lucky. 10 degrees drop for new aircon unit is quite possible. As you can see, mine, I could only achieve 8 degrees, which is 30.4 minus 22.3 as at the coil temperature, so you get 8 degrees there. And what about the calculation there? You can see that the compressor was 2.05 amps. You multiply that by 220 volts, you get 451 watts, and then you divide that by 8 degrees, which is the drop that I got, only 8 degrees, and giving me average of 56 watts per degree for per degree, and that's the cost. But bear in mind that this calculation, this 450 divided by 8, is a linear calculation, and is actually, the temperature drop is actually exponential to the cost. So this is actually a very conservative figure. And as you can see, the coil temperature was at difference of 1.4, and you multiply that by number of watts, which is 56 watts per degree, giving me a total of 78 watts equivalent of cooling, extra cooling, yeah. And 0.1 amp multiplied by 220 volts, giving me a total of 22 watts of cost saving. So total I would enjoy is 100 watts. So you multiply that by number of hours, number of days, and number of months, and you get to enjoy the cost saving on your electric bill. And bear in mind that this is a very tedious job and requires a lot of patience. Every time you purge the suction line, you have to wait for half an hour, and sometimes the pressure tends to creep up as the system stabilizes, and heat in the plumbing, in the gas, the heat in the gas rises, so it will creep up, and you have to keep purging until you see 150 psi. So it's a very tedious job. It takes time and patience. That is why most of the technicians do not like to wait for 2 hours, because time equals money.